So the speed state audio is effectively the wind noise that occurs whenever the player gradually starts to move faster. So when the player is stationary, there isn't any wind noise, and then it increases from a speed state of low to a speed state of high. So the speed state low is a lower frequency sort of wind loop, and that just loops constantly. And then the high one is a higher frequency. So the way these work is we have these set up on our player prefab here. We have them on the VFX slipstream object. This is just to keep it out of the way because I'm using two sources, one for each of the speed states. So the player has other audio on them. I didn't really want to make a mess of audio sources, so these are kept away in their own object, and they're set to play on awake and loop. And then in our script, on start, we just get every component that we need, and we get our two sources as source low and source high. And on start, we set both these volumes to 0, so there shouldn't be any audio when the game just starts because the player isn't moving. Value is set to the speed of the character. So when the character isn't moving, so the speed is 0, there should be no audio. And then it gradually increases through the low state, then to the high state as the player reaches their maximum speed. So I decided that the maximum speed should be a value of 120 based on the magnitude of the velocity of the rigid body. The player can go a bit faster than this, but I decided to cap it at 120 because you still want to be able to hear the maximum fast audio state whilst you're going faster than that speed. Because if you just had it at whatever the cap speed was, then you would only hear it if you managed to actually reach maximum speed, which the player isn't really likely to be at that at constant times. So the max speed is 120. So what this update does is every frame it turns our variable speed to equal the magnitude of the rigid body. If that speed is greater than 120, then just cap it, and then trigger this volume update function. So volume update, therefore, is called every frame, and this is what sets the volume of the two audio sources. So the first thing we need to do is our speed scale is 0 to 120, but we need to map that to a source volume scale of 0 to 1. So this function essentially takes care of that. This is an equation of its own, but since the values aren't changing, I felt comfortable just writing in what the output value is. So what this does is it takes the maximum value minus the minimum value of the new scale, which is 1, divide it by the maximum value minus the minimum value of the old scale, which would be 120. So 1 over 120 is 0.008. And then we multiply that by the value that we are needing to transform, minus the value of the max of our old scale, plus the max of our new scale. So this will linearly transform any number on a scale of 0 to 120 onto a scale of 0 to 1. So if we had 60 on our old scale, that would be 0.5 on our new one. So for volume low, what we need to do is we need it to be 0 when the speed is 0. We need to then increase to 1 whenever the volume scale value is 0.5, and then linearly decrease back to 0 when the volume scale equals 1, because we want this to sort of be the middle source. We want to go from no state to the low state to the high state, so we need this to be max in the middle. So the way I did that was, instead of going on a scale of 0 to 0.5 to 1, I just multiplied it by 2 because that made the numbers a bit easier of going from 0 to 1 to 2. This was also easier because on our volume scale, we need it to go to 0 to 1 as max volume whenever it needs to be max volume. By multiplying by 2, our scale now is 0 to 1 to 2, and we have 1 as the max volume. Therefore, we don't need to do anything for the 0 to 1 part because that's all taken care of. It's all in the right scale. However, when it's greater than 1, we still need to linearly decrease it back down to 0. So the way to do that was just, if it's greater than 1, we need to minus our volume low from 2, so that it'll scale up to 1 and then back down to 0. For the volume high scale, I just kept this as a scale of 0 to 1. If the volume scale is less than or equal to 0.5, we don't want any audio because this is still muted for the volume high, so we equal that to 0. Otherwise, we do want the volume to be from 0 to 1 on the speed scale of 0.5 to 1. So we need to do the same thing that we did up here of linearly transforming it onto this new scale. So this just sets, instead of being on a scale of 0.5 to 1, we move that onto a scale of 0 to 1, but it will obviously, the volume of 0 is still gets triggered on the volume scale of 0.5, so that all works perfectly fine. And then we just set the sources due to what the calculations are, and that sounds like this. FadeMixerGroup is a script I've written to handle the fading of all parameters within the game within the mixer. So this fades everything from the volume of different mixer groups to the low pass settings on specific effects. So the way it works is this is a public static class with a public static IEnumerator. So this could be called from anywhere. You just need to start the coroutine and call start fade. The parameters that you pass are the mixer that contains the parameter that you need, the name of the exposed parameter you're wanting faded, the duration for the fade, the target value, time, which is just time.delta time, and a bool for whether or not this parameter is a fader parameter. This is important because if it is a fader parameter and it uses a logarithmic scale, then we need to actually change the linear 0 to 1 value that we're passing through this onto that logarithmic scale. So if you were fading out the volume of a mixer group, that technically is going down to minus 80 decibels. So that's what we want our 0 to be. So we just need to figure out how to map the linear 0 to 1 scale onto the logarithmic decibel scale. So at the start here, we just reset all the variables that we are using, and we get the float of our exposed parameter that we're wanting and set that to the current value. If the bool fader is set to true, then this is a volume parameter. Therefore, we need to calculate what the linear current and target values would be from the given log values that we've gotten from getFloat. So in our fade loop, this lasts as long as the duration that we've passed is, and we increase current time with the time.delta time. And what we do is we get our new value from lerping between our current value to our target value based on where we are on the current time over duration. And that'll give us our new value. So now we just need to set it. If true for fader, then again, this needs to be a logarithmic value. So we just set it as a logarithmic value based on our linear value. Else we can just set this float directly, and then that'll save it as the new value. And this just repeats for the duration, and then that's your parameter faded. And the way this is called in scripts, if we go back to our speed state audio script, we have functions here for pausing and resuming the audio, which are just set up to fade in and fade out the volume of these speed state audios. All we have to do is start coroutine, and then our script FadeMixerGroup and our function start fade, pass along these values. So we've set our mixer, we've set a string for our volume of our character, the duration of 0.2, so it should take 0.2 seconds. For pausing, we want it to end up at 0. For resuming, we want it to be 1. Metronome.time, which is just another method I've made to get the time.delta time. And true, because since it's a volume that we're fading here, therefore it's a fader parameter, and we need to factor in that it's logarithmic. So to bring a bit more life into the game, we decided to make certain UI elements pulse in time with the music. So what this looks like is, on the main menu, we have our title and our play button. They pulse on every third beat of a bar, which is the snare beat. And then these kind of sprays in the background, these all pulse closer and further away over two bar periods. So that looks like this. So the way this all keeps in time and gets triggered when it needs to is through our Conductor Script here. So the way that this is working is this handles a lot of things, but for our purposes for the pulse is we have certain variables for BPM, crotchet, song position, DSP time song, last beat, last bar, offset, and time takes are the main ones that handle this system. So on start, we need to set some of these variables. So our BPM, I know that our BPM for this song is 200, so we can just set that in the editor. Theoretically, we could put in a new song that had a different BPM, and then with a couple tweaks, the system would be working up again. But for this one, the song is 200. So on start, we want to calculate a crotchet, which would be 60 divided by 200, which is 0.3. So a crotchet occurs, therefore, every 0.3 seconds. Our bar, therefore, is crotchet times 4, which is 1.2 seconds. We need to set our DSP time song, which is the audio settings.dsp time for whenever the song was started. So if that variable is 0, which it should be on start, then it should equal audio settings.dsp time. And this audio settings.dsp time essentially is the time of in this case, the Unity project being run. Or if you were actually running it from an application, it's just the DSP time of that application. So if I was to go back to the editor and play the game, and then stop it and then play it again, this DSP time song would be two different values because it doesn't reset based on, the game playing. It resets on the application reset. So we also have an offset variable which was set to 0.05. This is essentially just kind of whenever the game is started, it takes a very short amount of time to actually get up and running. This offset was trial and error essentially of just whenever we use this value to kind of offset the whole system, it makes it run a lot smoother for our purposes. So that's everything set up in our start. And then our update function is what handles triggering the pulses. So we need to get our song position. Every frame, we do song position equals the audio settings.dsp time minus our DSP time song. So this DSP time again is constantly updating every frame for the current time of the audio system, whereas our DSP time song is saved at what that value was whenever the game and thus the song started at. So if we do DSP time constantly changing minus our saved DSP time song position essentially equals a timer for how long the song has been playing. So if song position equaled 10, then the song has been playing for 10 seconds. And we also minused our offset here, just because, again, this made our system work a lot smoother in terms of timing. So we have two different kinds of pulses that we're doing. We're doing pulses on the beats, which were the title and the play button, and pulses on the bars, which were the kind of spray paint elements in the background. So to talk about the beats, if song position is greater than the last beat plus bar minus times takes doubled. So last beat, since we've just started, last beat should be 0 because it has been set, plus bar, which is 1.2, minus time takes multiplied by 2. This is similar to the offset of it was trial and error to get this to actually sync up properly with the system, because there's some inherent delay within the computation. This was honestly just trial and error of whenever we implemented it like this, it worked well for our purposes. So this isn't necessarily fit for any implementation of this. But to talk specifically about last beat and bar. So if song position is greater than last beat, which is 0, plus bar, which is 1.2. So if song position is greater than 1.2, we know that the song is past 1.2 seconds, which is where we want to trigger a beat pulse. So if it does pass that, assuming that the music isn't muted, because we don't really want the pulse to happen if the music isn't playing, because it wouldn't really make sense. Assuming it's not muted, then we trigger our beat pulse, and then we set our last beat to equal itself plus a bar. So this last beat parameter will just keep plussing itself, essentially. So last beat equals 0 for the first one, then it'll equal 1.2. So for the next beat, if song position is greater than 1.2 plus 1.2 because another bar has passed, then we trigger it again. So this will keep happening every 4 beats based on the first beat. For our bar pulse, it's very similar. If song position is greater than last bar minus offset plus crotchet. Offset, again, was just trial and error of it makes our system work better. And so essentially it is song position is greater than last bar plus crotchet. Crotchet was added in, I think, because there was an issue of it playing sort of on the wrong beat in terms of the music, so it was either playing, you know, on the 4th beat or the 2nd beat or something. For our purposes, adding crotchet in made it happen when we wanted it to happen. So this essentially is just song position is greater than last bar. If so, and assuming not muted, then trigger the bar pulse, and then last bar is equal to itself plus 2 bars. Because we want this pulse to last over the length of 2 bars. It pulses in and then it pulses back out over the length of 2 bars. And then, if the song's been playing long enough that it actually starts to loop again, we had an issue where it was sort of running out of sync, or theoretically, it would run out of sync if consistently looped over and over again over a matter of, hours. It would gradually fall out of sync. So to combat that, we just did if song position is equal to or greater than 116.4, which is the last sample and frame of the song, then our DSP time song, we set that to the DSP time of the system again. So DSP time song is reset to what the system is currently now, and our last beat is set to 0. And then that just allows this to keep running in sync with the same sync that it had on the first play of the song. So even if there were inherent sort of sync changes that were happening towards the end of the song, it will never, repeat. It will always just kind of set itself back to working how it should.